So we toss around the word function a lot, and a lot of times we use it synonymously or the same as we use the word equation. But actually a function has a special rule that makes it a function, and here's that rule. A function only has one output for each input. Okay, one output for each input. So what that means is that for every x, every value of x along my x-axis, I can only have one height, or 1 point really, over that x value. If I have multiple points stacked on top of each other, that means it is not a function. It's still a graph, but it's not a function anymore. So we can test that by just looking at our graphs and doing something that is called the vertical line test. And the vertical line test really is to just draw a vertical line through your graph and see if it hits more than once. Because if it does hit more than once, that means that my points are stacked on top of each other and it is no longer a function. So, looking at this example, if I were to draw a vertical line through any single point on my graph, anywhere all the way through, notice I'm only hitting one time, right? Anywhere I draw it through, it's only hitting it once, which means that this passes the vertical line test and that this is a function. Okay, so f of x in this situation would be a function. Let's look at h of x down here. H of x, if I draw my vertical line, look what happens. Uh-oh. I hit twice. That means that at whatever x value this is, it's having two outputs. An output up here and an output down here. That is not okay. So this is not a function because it failed the vertical line test. It hit twice. Okay. Let's think about a table. A table, if I'm looking at this, I want only one output for each input. So I need to make sure that my input is not repeating itself, right? So if I look here, I have a 2 that's at a height of 0, but I also have a 2 that's at a height of 4, right? So I have two different outputs for that same input value, which means that this would not be a function. A new vocabulary word for us is invertible. So if you are being asked if a function is invertible, what that means is the function's inverse a function? In other words, if you switch x and y in your original, will that new function also pass the vertical line test? Okay. So for this one, we're switching it. So we're trying to see if every output has one input. Okay. So to test that, instead of a vertical line test, I'm going to want to check my outputs and go this way, horizontal line test. Okay. Same idea. If it hits twice, then that inverse would not be a function. It is therefore not invertible. Okay. So this one, it passes here, but look, it does not pass here. Okay. So this one would be not invertible. Okay. This one, going through, every single time it only hits once. So it passes the horizontal line test. So this one would be invertible. And this one, instead of looking at my x's for repetition, I'm going to look at my y's for repetition. These are not repeating, so this one would be invertible as well because my y's don't repeat, my outputs don't repeat. Last thing you may be asked to do with functions and this idea of being invertible is to take a function that is not invertible and force it to be invertible. What that means is that instead of looking at my whole graph, I'm just going to find a section of it where it would pass that horizontal line test or where it would be invertible. Okay? So you can have a lot of different correct answers for this one, but let's look at the different places that I could chunk my graph off to make it invertible. Okay? So my problem area is this hump right here because I have those two inputs giving me the same output. Or sorry, yes, two inputs giving me the same output. So what I want to do is break that up. I want to divide it. So in order to do this, you should have numbers on your graph. So let's just call this -2. We're going to estimate and say that's about 2. Okay. So what I could say is that from -infinity all the way to the left, all the way up until about -2, okay, my graph would be invertible. I could, if I ignored this part and just drew little horizontal lines here, they would all pass. Okay, so this is one interval where my graph would be invertible. Okay. It would also be invertible between 2 and 2, because this is my next problem area. That hump is representing my next problem area. So I'm going to break that up. So between -2 and 2, it would be invertible. And then I could also say that from 2 to infinity, it is invertible. So essentially what you're doing here is you're just looking at sections of the graph and seeing which sections would pass the horizontal line test if I ignored everything else.